Computer malware naturally runs in a hostile environment. You've got antivirus, you've got EDR, you've got all these other security mechanisms and defenses fighting to detect or prevent and stop malware from running. And rightfully so, right? Because it's malware. But if you are a security researcher, sometimes you want to see that malware in action. Or if you're a penetration tester or an ethical hacker or red teamer, a threat emulation team, you want to run and write and make malware. So your malware needs to get around these defensive technologies. It needs to bypass it, it needs to circumvent it, it needs to evade things like antivirus, EDR, and all these things that are in the way. You need a little bit of evasion in your toolkit, and in this video, I want to show you one of the ways that you could do some cool evasion techniques. But before we dive in, before we go too far, I want to just add a little bit of background. So the thing is, just for some added context, when you run a program on your computer, when you fire up applications, those can run really in different locations, right? It can be in user space, right? When you just start a program, click on an icon on your desktop, and maybe that will run as a low privilege user or just medium integrity as just a user starting that application. Or the administrator could run. It could start as sort of a high integrity process. And of course, you've got that lower level stuff that is all in the kernel, the real roots of your operating system in your computer, the kernel space where all those drivers might be controlling how your computer functions. Code sits at a super low level there, and maybe your application, your malware, might not be a kernel level rootkit. But if you're still writing user-land malware, then you need to know the EDR, the endpoint detection and response software that you're up against, probably has some hooks and kernel callbacks and is monitoring things on the disk, on the file system, network traffic, etc. And then of course, hey, all those user processes are going to be interacting with an EDR DLL. That security solution might be logging for things like changes in the Windows registry, stuff happening in memory, maybe stuff across the firewall or proxies or VPNs, virtual private networks, and all of these are a single point of failure in that your malware could be detected at any point. And with that, the jig is up. You failed the campaign, the ethical hacking effort, your penetration test, or your red team mission has failed. Maybe you just can't get your implant to run or the beacon to fire, and that is why we need to learn a little bit of evasion. Oh, and by the way, if you are like fascinated by this stuff like I am, like if you just think this is awesome and so cool and you want to learn more about it, hey, the visuals that I'm showcasing, what I'm bringing to the table here is stuff from the Sector 7 Institute, which is some awesome and incredible means to learn malware development, to learn evasion, and all of the incredible offensive security research and techniques. So to bring this to life, I want to showcase a little demonstration where we can spoof the parent process ID for an application or program that we run. Like, you know, the parent-child lineage like you might see in Task Manager or anything that you use to view processes. We can actually fake what a program looks like it started from that your EDR or technology in AV might actually be trying to dig into to determine if there's malicious behavior. It is one of the tricks and techniques we can use for a little bit of evasion. But first, I'm learning all this through Sector 7's evasion course. I'm learning so much and it's so cool, and if you don't mind, I'd love to tell you a little bit about it. Special thank you to Sector 7 as this video's sponsor. Sector 7 Institute in the Windows Malware Evasion course. If you're a red teamer or a penetration tester, you're certainly writing your own implants in malware. Or at the very least, you should be. But your implants need to evade detection by EDRs, antivirus, and other preventive security solutions. With Sector 7's evasion course, you're provided a class virtual machine and code where you learn evasion techniques from both perspectives of a non-privileged user and a high-integrity administrator. You manipulate binaries entropy, modules, and signatures, and learn process unhooking, parent process ID spoofing, command line spoofing, and how to blind certain technologies, like event logs, tracing, firewalls, and other detection efforts. Now, with English subtitles, new material, and supplemental information, you can learn how to make your malware evade defenses. And I've said before, Sector 7 sets the bar for red team training in our industry. They teach incredible material, and I am so excited to partner with them to offer 20% off their Windows Evasion course. Get started learning top-class red teaming and malware development with the Sector 7 Institute. You can use my link below in the video description, jh.live/evasion. Huge thanks to Sector 7 for sponsoring this video. Alright, so I am on my host machine. This is my desktop. I'm running Windows Defender as my antivirus. I have Huntress installed as my EDR, and I'm going to fire up Visual Studio 2019. We're going to write some C and C++ code to be able to work with the Windows API. So I am going to create a new project, an empty project from scratch with just Windows here as an implementation. And I can just call this PPID spoofing for parent process ID spoofing. And that way we can go and create this here. And now that that solution is created, we can go into the Solution Explorer and add a new item for just the source.cpp. Let's go ahead and create that and we can start slinging some code together. All right, so first things first, we're obviously going to add in our usual includes for some shady malware. Let's get the Windows header file. Let's get standard IO. Let's get standard lib. Let's get strings, TL help, and PS API for process handling and for some of the snapshot stuff that we could do to list some of those processes. And listing the processes is exactly the first thing that we need to do. We need to have that functionality because if we're trying to spoof a parent process ID for some application and program that we start up, well, we need to know what programs are already running on the target environment in the system here. So we could just start something simple. We could do like, oh, explorer.exe. That way, okay, the Windows graphical desktop interface is normal and natural other than us just, hey, spawning a process underneath our own running implant or malware, right? If we were building some sort of launcher or cradle or something to stage another payload, we wouldn't want it to look like it's just under our process. So I am going to build out the usual kind of process for retrieving a process ID based off of its name. We're going to pass in just a wide character string that is a pointer referring to the process name that we'd like to end up pulling down. And we need to create a couple structures, or at least we need to define a couple structures that we know we're going to end up using. And this is the process of using like the process entry snapshots and that create tool help 32 snapshot thing that Windows offers as part of the Windows API. So we need a handle for the snapshot. We're going to need to actually define the structure of the size, the size of the structure, right? Reverse that in my mind. That is just one of the sort of like oddball boilerplate sort of necessary things that you have to do when you use this technique. You specified the process entry sort of structure that you're going to end up using that you've defined up above in the process entry 32. You set its DW size sort of attribute and property to the size of the process entry 32 structure that you know that you're working with to begin with here. Then we can go ahead and actually fill in our snapshot variable, actually set that to the return value from our create tool help 32 snapshot. That's the one. Thank you, Visual Studio, for filling that in for me because I always forget. And the constant here that you need is the tool helper 32 snap process with CS in there and 0 following that. That is, what is that other argument? What is you going to tell me, Visual Studio? Oh, the process ID. Yeah, we can just say 0 as null to start. Now we're going to end up looping through all of the processes and iterating through them with the process 32 first function and the process 32 next. This is actually like the most common method or one that you'll see all the time for kind of just, hey, just checking what running processes are on the system. The way we get that going is actually checking if we still have a actual result, if there is a first entry or result on our snapshot that will fill in to our p entry structure. That variable that we'll just use the ampersand to refer to the reference there, and we'll check if that actually returns something with an if equals true. If it did, if it actually succeeded, we can go ahead and start a little while loop. We'll use that process 32 next function where we have the exact same sort of structure for our arguments here. We'll pass in our snapshot handle and our process entry with its reference here. Check if that is equal to true to see we've actually got another item in the list. And then we can go ahead and compare. We can go ahead and check if the process that we're looking at currently matches the same name for the one that we're looking for. So that way I can specify, I want explorer.exe, and we'll pull it from the list and grab the process ID based off of the snapshot that's been given to us by Windows. So let's fill that out. Let's use WCSC compare, which is like the wide C string compare, I believe, because we know that the P entry little structure here, one of the properties for that SZEXE file is a wide string. It is like whatever UTF-16 thing. I think I might get that wrong. Forgive me. But the P name that we'll end up passing in, we know is what we're going to end up checking that with. And we'll have to precede that with like the capital L for our code here. But we'll validate and verify, okay, there are no differences. The string compare returns 0. There are no differences. So it is the same string. That is the string that we're looking for. So we should go ahead and return the current entry that we have in our list, P entry, and its TH32 process ID. Now we have the process ID for the process that we wanted based off of its name. That's good functionality. Okay, so now we can get into the main function, the actual operations of our application, our program here, where we are going to execute an application and then spoof the parent process ID. And I think this trick is kind of cool because you're basically stealing some information from the already running process that you want to sort of masquerade underneath. So let's define our main function here. We'll keep it kind of easy, like no command line parameters or whatever, but we will want to create a process, right? We'll create process A as you normally would, and then you'll fill in whatever regular boilerplate stuff for, the process things that you need, but we'll specifically want to actually spawn notepad.exe. And then the usual defaults that you need, like a couple nulls, null for default security attributes, inherit handles can be false. Now, when we get to the creation flags parameter and argument, this is where the secret sauce gets poured in, because we can supply something interesting like extended startup info. That is what can be present, and that is where we'll actually specify, look, later on, after we cruise through those other necessary default boilerplate stuff, we're actually going to end up doing a couple placeholders, because ultimately, I'm going to end up creating some code above this, and that is what's going to make the difference between our regular process that we spawn and our code that we'll use to kind of set up and structure our spoofed parent process and process ID. So bear with me here while we leave those as placeholders, but back up top, before we create process, we're going to do a couple things that will actually stage the startup info that we'll want to pass to this process that will start. We need a startup info X structure. We can just define that as info for now. Next, we'll need something for our process information. Next, we'll need our usual process information structure that you typically pass in to our create process here. But now we'll get into the other more interesting things that we need to be able to manipulate our extended startup info. Now we'll get into the other important pieces that we need for this technique, where we can actually take advantage of this extended startup info. We've got that structure up here, but one of the really cool things about it is that you can actually include and update and modify and play with this one other property called an attribute list. And the attribute list can actually kind of be customized and made and whatever we want it to be, and we can use that to steal and swipe from this parent process that we want to spoof. In this case, Explorer. Right? So first things first, let's define those structures. We need an attribute list size. We need a pproc thread attribute list. That's a big one. Thank you for filling that in for me. We can just call that p attribute list, set it to null for now, as we're just declaring these things. We'll create a handle for our Explorer process. That can, of course, be null for now. And then our D word for our DW, like D word, our Explorer PID. That can be 0 for the time being. But now we know that we actually want to retrieve the PID based off of our get PID by name function that we defined above. And remember, that has to be a long string for the wide characters. And we're going to be looking for explorer.exe. Now, let me add just a fallback in case for whatever reason I get this wrong, which is pretty likely. And I don't know, maybe something just goes wrong, something happens the wrong way. If it happens to be 0, if it isn't able to return anything and we just gave it, I don't know, 0, nothing came out of that, then we can go ahead and set that to our current process ID. So it will just sort of naturally come from this implant or the beacon that we're trying to stage here. All right, now let's do the magic for actually creating our own attribute list. First things first, we'll need to initialize our proc thread attribute list. That's the one. And the parameters here, again, thank you Visual Studio for filling that in. We have an attribute list parameter, a dword attribute count, DW flags, and an LP size. These can, just kind of at least to get the ball rolling, be null, be 1, and be 0. And the LP size should basically be our CB attribute list size as we defined just up top. That is an out parameter. It's going to end up filling in for our pass by reference argument and type that we have up there. So that should be good. And now we'll say our actual attribute list, right? Our P attribute list, we'll set that equal to a cast pproc thread attribute list. It didn't auto-complete that for me and I'm sad. Let's go ahead and allocate some memory on the heap. We're just trying to get some place in memory that we can safely store this so we can define, create, and craft our own attribute list. We'll give it our current process heap with no flags, and the DW bytes should be the attribute list size that we've already kind of filled in previously. Attribute list size. There we go. Now that that's been created in memory with the proper size, we can actually just fill that in. Rather than passing null as this argument here, we'll go ahead and create and use our P attribute list that we've just kind of allocated in memory here for us. Okay, now it's time for the trick. Now we can actually open up explorer.exe, like the Windows desktop GUI application, grab its handle, and then try to steal and swipe some of the process info and attribute lists that it has, and then be able to pull its parent process ID and use that for our Notepad application. So let's get to it, and let's say that our hExplorer process variable can be the return value of our open process function. That'll go ahead and return the handle to our explorer.exe. We'll specify process all access, and we'll specify, hey, we don't need to inherit anything, that can just be false, and the D word process ID is the DW Explorer PID and process ID that we've previously retrieved thanks to our get PID by name little methodology with that process 32 first and process 32 next under the Win32 tool help snapshot thing. Does that make sense? Now that we've got that process handle, we can actually update our proc thread attributes based off of the P attribute list that we created, 0 for our DW flags argument, and the attribute that we want is that proc thread attributes, and you can see there are a ton of these, but the worthwhile one as I'm scrolling through up and down with my arrow keys here is the attribute parent process, because we can swipe that and we'll pass in the address to the handle of our parent process. In this case, we know that is our Explorer process that we want to steal. It can be the size of a handle based off of that CB size argument, and then the last couple of arguments for the LP previous value and the return size can just be super duper easy null. And with that, it's good. But we have one last component here because we need to end up passing something into our create process A function while we create our notepad.exe, right? So I kind of sort of lied to you in that the very last argument doesn't really need to rely or depend on some of the previous code. The process info as the last argument here is really something that we kind of already created, and that's just an output variable for the parameter that's passed into create process. But the info that we use as our startup info is actually super duper important, because now that we've actually pulled this info and attribute list that we want to actually give to our startup info extended structure, we'll actually have to tie that together. We'll have to say that info little variable that we created up here, our startup info X, remember, that can actually specify the LP attribute list, and we can set that equal to our new custom created attribute list that has swiped and stolen Explorer as the parent process. Now that info structure, that variable, that startup info X type, is all that we need to end up passing in for our last placeholder here. That does need to be cast into an LP startup info A, that's the one, with our info.startupInfo, and we can remove the trailing comma for that last argument and then call that function done. We do have just a little bit of cleanup to do though. It would be worthwhile if we actually could print out maybe our malware PID with the little D word included as our get current process ID, correct? Let's also add the Explorer PID, and that should be our, we know it already because we actually pulled it, our Explorer PID, correct? And then finally, let's go ahead and say our Notepad PID, which should come in the process infrastructure that has been kind of output. We can say our process info, what is that? DW process ID. Nice. Now that we've got a little bit of output, we can go ahead and sleep for, I don't know, a little bit of time. That way we can see the thing run, and then we can cleanly delete proc thread attribute list, some of the dangling stuff from this little memory that we created for us, and then we'll ultimately close the handle on our hExplorer process because we don't need that anymore. So with that, I think we're done. I think like what? I don't know. We made for 75, 76 or so lines of C code, a little bit of a couple new lines in there, but that should be it. Fingers crossed. Anyway, hopefully I didn't make any mistakes here. Let me go ahead and try to build this. I'll go ahead and Control B. Looks like it succeeded. I see a little console output is telling me it's all good. So what I'm going to do is I'm going to copy just this path here. And you know what? Maybe we should just be in release mode. Release 64-bit architecture. That way we're cool and we're elite. Doing it the real way. Can build one more time. Still succeeded, so we are good to go. Let me copy that path. I'll fire up a terminal here. Full screen this, and let me change directory into that location. We do have our PPID spoofing.exe, and let's fire it up. So, fingers crossed, all we see from the user is Notepad firing up. There it is. We have our malware PID, that is our PPID spoofing.exe that we just ran, and that is 32220. We have our Explorer PID 100752 and 37752. Now, obviously, just with the process ID, there's really no correlation, but ultimately we should fire up something like Procmon, Process Explorer, anything that we could actually use to see how these are kind of child and parent processed aligned. Now, our sleep line has just ended, so what I'm going to do is actually close this notepad, and I'm going to go fire up sysinternal suite, and I want Proc Explorer 64-bit. Does that work? Cool, fired up over here. Now we've got that running. Let me go put these together in sort of separate places. Okay, side by side. Now I don't know how well you can see over here on the left for my Process Explorer, but you'll note that I do have this command prompt open, right? Here's my Windows terminal with open console PowerShell.exe. What I'm gonna do is I'm going to start my PPID spoofing.exe executable. Here comes Notepad. You can take a look that PPID spoofing is not actually running Notepad underneath it. You can see the malware is 21268, and that is, of course, the process ID for PPID spoofing. Notepad is 38548, but it is not under PowerShell. It is not under my PPID spoofing.exe. It's along the same lines as Windows Terminal in the vertical kind of distance here, and you can see that across my Brave browser, my Sublime Text window, OBS running to record here. If I bring this all the way down, collapse all these, you can see that it is a process underneath Explorer.exe. If I actually go ahead and right click, let me check out the properties here. Check it out. The parent is Explorer.exe. It's as if I just double click this, ran it, and fired it up from Windows. Now, obviously, this is a pretty primitive example, right? We're not using any weaponized detonating payload and actual malware, no sliver, beacon, and implant to fire up here. Just trying it small and simple with Notepad and Explorer, but I hope that proof of concept kind of drives the point home, because you could obviously use this technique for anything that you want. It doesn't have to come from Explorer. You could make it be whatever. You could have other things that happen in your implant or beacon or your malware, and you can get creative. Have some fun. It's your world, my friend. I'm just living in it. And hey, I gotta say, this is all new to me. I'm still learning. I'm still figuring this out. I'm having fun with it, and it's just really, really cool. But look, I gotta give the shout out to Sector 7 because they take this example, they run with it, and then they take it even further. And of course, by the way, you have a virtual machine for the whole course. Let me fire it up real quick. Here, they're supporting VirtualBox, so it's super duper easy. No issues with getting the OVA kicked up. You can set up like a shared folder and get code back and forth, not have to worry about the antivirus stuff getting in the way. And here is the virtual machine. Nice and easy. It already has Process Hacker. It already has x6040 debug. It already has some of the Visual Studio Code, SDK, everything that you might need. It is pretty great and easy to get you just thrown into the environment so you can start to write some malware. They do actually showcase this all in the evasion techniques up against Bitdefender. You can see Bitdefender antivirus here, and they do use Sysmon as the EDR capability, which is kind of interesting and all the things that they can dig into, but I do want to give that shout out, and you've got the virtual machine to play with. I, for one, think it's really, really cool that they're going up against Bitdefender and Sysmon, because like, those are legit, that's real. People use Bitdefender and Sysmon. So anyway, take a look. This is the parent process ID spoofing that I just wanted to showcase for you in a little bit of a demo. They walk through all this and give you sort of the code snippets. They explain each component, each part and piece that I probably failed to dig into, but they take it even further when they showcase the other methods and tricks that you can use to do this exact same thing, like using the Windows Task Scheduler. One crazy technique you could dig into, sorry, I said trick and technique at the same time. One crazy technique you can dig into is actually getting into COM, like the Windows Common Object Model, and this is for so much stuff within Windows, and they make it super duper easy to actually dig into what that code looks like and how you can put it together. I'll go ahead and get a video started here. The thing is with like COM and even WMI in the next section, like you can make your operations, your malware, your behavior, what you do, basically oblivious to what SOC analysts or security operations center might dig into. Like unless they really know what they're looking for, which they won't kind of at the start here, at the investigation, they are just blind to what's going on. And that's kind of wild. But they showcase just how easy it is to write a whole lot of that code, co-initialize, co-create instance, stuff that you'll end up doing to work with COM objects, and they even do some command line argument spoofing once you're done with some of the parent process spoofing. And the Emotet method is really slick because they use WMI, right? The Windows Management Instrumentation. And if you're using that alongside COM, the Common Object Model, I know that it sounds and seems like there's a whole lot to it, but these are really, really digestible with all the explanations that they offer and the code snippets that they showcase, like the declarations of the functions and the arguments that you need to know that you use, the parameter types, etc., etc. The thing is, you can do a whole lot with this, like manipulate the firewall or play with other Windows configurations, stuff that can just totally throw security analysts and maybe the defense blue team for a loop. That gives you a leg up as a red team operator and malware developer. And this is like just scratching the surface. Like that's all for the medium integrity, like regular non-privileged user vector. Once you get into the high privileged user vector, then you can start killing like ETW and event log and so much wild stuff. Holy goodness, this has turned into a long video, but man, I sure hope you had fun. This has been really, really cool. I know there's a whole lot to dig into here, but it's a wild world, and I think folks really kind of dig and having a whole lot of fun with some of the maldev and malware creation, red teaming, ethical hacking, pen testy stuff. So I hope you had just as much fun with this video as I did. I hope you're learning some new stuff, and I hope you're, hey, kicking it with Sector 7, having some fun and digging into it. Huge thanks again to them for sponsoring this video. If you want to start the party, link in the description. Thanks so much for watching, everyone. I hope you enjoyed this video. Like, comment, subscribe, YouTube algorithm stuff. I'll see you in the next one.